All right, cool. So my name is Eric Messick, and I'm at Oklahoma State University, and yeah, I'm part of the RAIN program. And so the title of my project was The Effects of Early Nitrogen Deprivation on the Root Systems of Wheat Plants. And this project involves me, Carson Wright, Tegan Crosswheat, Giles Souza, and then Brian Arnold. And with that, let me get started. So it's well known that nitrogen is a pretty essential nutrient for plant growth. It's in a lot of the fertilizers that farmers use, and it really helps increase the yield. But we ask the question of what happens when plants are intentionally derived nitrogen during their early growth stages. And there was some past research that indicated that the early nitrogen deprivation helped to cause the roots of plants to grow larger, and it caused them to grow longer and seek out the nitrogen within the soil. And then by doing this, it also helps them become more efficient, and become more cost effective. It helps the plants reduce their nitrogen loss, promotes nutrient absorption, and it can even help the plants retain water better. And so the objective of our study was we wanted to investigate whether the early nitrogen deprivation causes the root systems of wheat plants to become larger further, and to find that we wanted to look at the final root to shoot ratio. And with that, moving on to the material sections, we had about 80 50 milliliter tubes, rock wool, DI water, and then we used 4 genetic varieties of wheat for the test. We had GH for Green Hammer, IBA for IBA, DS for Don't Stop, and Gal for Gallagher. And we chose these genetic varieties just because they're pretty common for farmers to use. And then moving on to the nutrient solutions. In the nutrient solutions, it had all like calcium, potassium, magnesium, sodium, had a bunch of the micronutrients plants need, and then we had a trial for either positive or negative nitrogen. And in the method section, we wanted to do a positive and negative control group for the nitrogen. In each group, there's going to be about 40 tubes, and we filled these tubes with rock wool. And then in figure 3 down here, you can see a close-up growth of the growth and like the rock wool medium. And the rock wool was really there just to hold the seeds in place. And also there's a hole at the bottom of the tube that allowed the rock wool to just like absorb whether it would be DI water or the nutrient solution to just keep the seeds wet. So in each group so each variety was given about 10 tubes, and we placed 3 seeds within them. And then the tubes were placed over a tray full of deionized water until they germinated. And then a few days after germination, we had 1 tray that was filled with a nutrient solution that included nitrogen, so our positive control, and the other tray was filled with a nutrient solution that excluded nitrogen. And then after about 3 weeks of growth, we terminated the growth. We measured the root and shoot length, and then we attained a dry mass by weighing the wheat samples onto a scale after putting them in an oven for 24 hours. In figure 1, you can just see the seed packets for the 4 genetic varieties of wheat. In figure 2, I included it just to give an overview of like the 2 trays. The one on the left is the positive control, and the one on the right is the negative. And just you can see all the rock wool, the tubes in line, and just, yeah, the early germination. And then in figure 4, you can see the final growth of the 2 groups. On the left side, you have the positive one with nitrogen. On the right, you have the one without nitrogen. And there's obviously a difference in the growth, but we weren't too interested in just the difference because, I mean, more likely than not, the one that has nitrogen is going to cause the plant to grow bigger because that's pretty well documented. But we're more interested into the final ratio between the shoot length to the root length. And yeah, that's what we're really wanting to test. So moving on to the results and discussion section. On the left, you can see the graph paper that we used to measure the shoot and root length. And then each square on the graph paper is approximately 1 centimeter tall. So you can just count those to measure how high they were. This was really a secondary measurement. The primary measurement we used was just like taking the masses of them to find the root to shoot ratio. But we took the average root mass for both the positive and negative, and we divided it out to get the root to shoot ratio. And I highlighted in yellow for you guys to see. But sadly, for the most part, the data we got was rather inconclusive, and we could not confidently say whether early nitrogen deprivation had a positive impact on the root to shoot ratio. But despite this, this study served like a starting point for the future investigation of like this topic. And it really helped to just see what methods worked, what methods can be improved on so other studies can be more efficient. And then we're going to analyze more methods and actions. We're going to tailor them to ensure that the future studies proceed in both a worthwhile and smooth manner. And just to give an example of something will change, we're going to test more varieties a week. But yeah, that really makes up all of my presentation. And I just want to say thank you to the RAIN program. And thank you to Brian Arnold for being my mentor. So that's it. Any questions?
All right. Thank you, Eric. Any questions?